and welcome back to another episode of the simple platformer game we are making. And I'm actually not continuing right where we last left off. Actually, I went ahead and already did the jumping. So last episode, if you were watching, if you haven't seen this yet, go back and watch the first episode, then come back here. But we were about to do jumping, and then we kind of cut it right there. But as you can see, I went ahead and did it, mostly because I wanted to make sure that I was doing it right and I got it all right the first time. But yes, we are doing simple jumping. We're not going to do anything like super fancy with the jumping. If you want to do more expanded jumping mechanics on your own, you can go right ahead. But as of right now, we're not going to do that. We're just going to keep it nice and simple. So as you can see, we were jumping around. And as you can see, we have a little jumping power here, and we are currently on the ground. And when we jump, we're no longer grounded, as you can see on the bottom right. And yeah, so with that said, we have some pretty simple jumping. I'll show you guys how to do that in a minute, but I want to make sure that you guys are aware that one of my subscribers, his name is Aurora, he went ahead and he actually made a bunch of art for us. So like a little, not like a bunch, but some art. And actually the plan is to kind of implement that today. So we'll get to that shortly as well. But right now, let's jump right into the code. And in here, as you can see, there's a bunch of new stuff. Okay, don't get overwhelmed. Okay, I'll explain it all. Okay, starting at the top, we added in jump power. Basically, jump power is basically the force that your person jumps up with. And then we also added in a boolean called grounded and set that to false. Oh, excuse me. So basically, a bool. If you're new to programming, a boolean is basically just true or false. Okay, there's no in between. It's just true or it's false. It is very simple. Actually, it is represented with a 0 or a 1, but in C sharp, which is what we're using, it is true or false. And make sure you do a serialized field because that lets us edit it in the inspector. We also made another boolean called is jumping and set that to false as well, but this is not seen in the inspector for, well, you don't really need to be able to see it in the inspector. And then this is where things get a little fancy. We've got a serialized field for a vector 3 ray placement. Now, a vector 3 is quite literally just like a transform up here. Your position is a vector 3. So basically, vector 3, the ray placement is right here. We got the x and the y, and as you can see, we have little values for that, which I'll get into in a second. We also have a layer mask, which is the ground layer. Layer mask is if you're not aware, actually you should go ahead and do this right now. Just go to your ground, your tile map that you called ground. Go in here and see where it says tag ground. Yeah, don't change that, but go over here next to it. It's neighbor and it's layer. Go to its layer and click the little drop down, click add layer, and then just type in ground in one of them. And then you just go back to the ground and use to assign it. Basically, that's going to allow us to easily detect when we're on a ground surface. And with that said, I went ahead and made a new function and I called it ground detection. If you're not aware of the function or a method is, basically it's just it's like what fixed update is. Fixed update is a function or a method. It lets you like write stuff inside it and then call it at any time. So basically I went ahead and made a void ground detection function. If you don't know what void means, actually for the longest time, for me starting out programming, I had no idea what void meant. I was so confused when people said void. Basically, it means that the function doesn't return anything, or its return value doesn't exist. Basically, in more common terms, when you call this function, you shouldn't expect to get a number back. You shouldn't expect to get like another variable back. You shouldn't expect to get anything back. You just call it like at the dead end functions. Like you just call it ground detection. It looks like it's calling nothing, but it's really not. You're actually, what you're doing is when this update function runs, it runs this code right here, and then it goes down to the ground detection, and it's like, all right, ground detection. And what it does is the when your computer's running it, instead of going down to like here or something, what it does is it jumps from this line right here to whatever line has the ground detection method on it, and then it runs everything inside of it. So basically, inside this ground detection thing, we have these new things called Raycast hit 2Ds. Okay, and I have 3 rays getting cast here. Now, basically, what a raycast is imagine shining a laser across your room. You're just shining it, at like a wall. Okay, now a raycast is what detects that wall. So, like your raycast is the laser, and when it hits the wall, it returns whatever that laser hit. So in this case, we're casting this laser or this ray at a specific point with in order to do a raycast, you have to do physics 2D and then do a dot to access the next thing, and then we do raycast. And then what you can do is we feed in that raycast placement variable, which we made up here. And then we just make sure we add our current position to it. If we don't add our current position to it, then what's going to happen is when we do the ray placement, it's going to go into the world and it's not going to do it underneath our character. It's just going to go wherever the world coordinates are that you put in for the ray placement. So just make sure you take account for your current position, which is just do this dot transform dot to this position. That's basically the player's current position. That's all that really means. And then, sorry, this is like a huge mouthful. Now we for the direction. The raycast takes in, as you can see, it's got. I can't really show you with my pointer here, but I'm gonna point to it. I'm gonna point to it on my screen. So you got your origin, you got your direction, your distance, and your layer mask. Editor, if you could just zoom in on that. I don't know. As you can see, it's got raycast, vector 2 origin, and it's got the direction, the distance, and the layer mask. Now, the origin is where you're starting it. Okay, the direction is which way do you want this ray to go? In this case, we want the ray to go down. So we do vector2 dot down. Basically, vector2 dot down is just a shorthand for saying, hey, I want the direction to go down 1 unit. Basically, it's the easiest way to describe it. And then the distance. The float distance is how far does this raycast go? Normally, raycasts go infinitely. They go in infinite like direction or whatever, infinite distance, but we don't want that. If we're trying to detect ground, we want to make sure it's on our feet, you know? So we just do one. Okay, just do one. It's just it seems like it's a long distance, but just leave it at one. Okay, one is the easiest to work with, especially with the current values that I have. And then we do ground layer. The ground layer is the layer mask up here that we made. And basically what we do is, I'll show you that in a second. But anyway, for these other raycasts, we have raycast 2 and 3. And raycast 2, actually, you know what? It'll be easier to explain this to you here in like this instead. Okay, if I can I hide? Damn. Okay, well, you know what? Well, we're just gonna move you over here. Okay, see, you see these 3 red laser beams, basically, right here. 3 red laser beams. I know they look like they're coming into our player, but believe me, it doesn't really matter. Right here is the detection area for ground. Now, if we were to land on ground on this side of our character or this side of our character, or we were on like a little pole, then we would detect it. So basically, we have the 3 rays. As you can see, the 3 rays are right here. Now we're casting them in different areas. Now, the first ray is casted right here on this side over here. And what it's doing is this placement right here is actually the location of this. That's what that actually is. Or is it this one? Actually, no, it's this one. It's this one. Sorry. Yeah, the raycast placement is actually the location of this one, I believe. And then what it's doing is it off of this one, it's creating these other ones as well. So if I were okay, I'm gonna remember it's 0.75, but if I were to change this, as you can see, this one also shrinks in, and that's because in the code here, it's actually being done down here, but this is the same code. Um, where is it? Raycast. Aha, it's right here. Okay. So we're making a new vector 3 inside this raycast function. Like we did just the same thing that we did for the velocity. We did a new vector 3 kind of. We did a new vector 3, and we're doing the opposite of this value. So instead of being a 0.3, it's negative 0.3, which is where we get this line right here. And then if you're wondering where we get this middle one, it's actually pretty simple. Instead of doing the x value of our ray placement variable, we just do 0. Pretty simple. And with all that said, I think you guys are probably following along because it's pretty simple stuff. Let's see here. Okay, so now we have an if statement in this function of ground detection. And basically what we're doing, oh gosh, hang on, I'm forgetting one thing. We gotta detect if ray3 dot collider is equal to null. I forgot to check the third one. Whoops. Whoopsie daisies. Okay, anyway, so now what it's doing is it goes through and it checks all the rays to see if anything exists. If nothing exists between all 3 of them, then we must not be grounded. There's no way we can be grounded if all 3 of those rays return nothing. So if there's nothing there, we grounded is equal to false. Otherwise, if any one of these has anything in it, then grounded is true because we are on ground, and then jumping is false because there's no way we can be jumping if we're standing on the ground. That makes sense. Let's see here. Now, moving on to this Gizmo stuff. This actually is a little bit more advanced, but it is pretty I mean, it's pretty straightforward. So gizmos dot color here. Basically, what we're doing is we're setting the color of these gizmos to red. So that's where we get these red lines from. If we didn't do that, these lines would appear as white. But I don't like that. I prefer to have red like outlines for debugging stuff. And then we just go ahead and we just draw the rays like we did up here. Except it does not take a length and it doesn't take a ground layer. You just give it the placement area and you just give it a direction. That's all you have to do. And then we should actually you should be up to date with all this stuff. So, with all that said, if you were following along, copying everything down, we should be able to do this. Uh, I think I did. I go over this ad for stuff. I don't think I did. So, in fixed update, underneath the horizontal movement, we go over the vertical movement. So basically, in an if statement, or if the player is currently grounded and he is not jumping currently, and the player is holding down that button for jumping, or holding the up arrow in this case, or pressing the up arrow, then what's going to happen is we add a force to our person, or we just make him kind of do like a jump upward. It's like a force that sends him upward. And then what we do is we say is jumping is true because he is jumping, and then he's no longer grounded because he just jumped. Um, Now, basically, what this is doing is actually exactly what this is doing is right here. I can just go ahead and show you right there. That's where the add force is coming into play right here. And it looks a little floaty, but that's because we're doing the basic simple platformer movement. If we wanted to put more effort into it, we would make it so, well, one, the longer you hold the button, the more intense your jump is. And then two, when you let go of the button, you're basically you fall at a much greater speed because otherwise it feels kind of floaty. But we're just not going to do that because if we're keeping it simple. And with that said, in the inspector down here, you just go ahead and copy what I have for these values. I did my best to make it relatively good. Jump power needs to be 200. I know it seems like a lot, but it's really not when you think about it in terms of forces. But make sure you set ground layer. Just click the drop down. You just click ground. That's all you got to do. Oh god, don't re-click it though. Don't do what I did. Otherwise it sets it to nothing. Okay, anyway, so now that we have jumping, I'm just gonna go ahead and do it one more time so you guys are following. We have jumping. It's pretty cool stuff. Pretty simple. Now what we're gonna do is actually implement art. Now this should be rather easy. I already went ahead and did it, but I guess I can walk you guys through it. Go into the description of this video and find the Dropbox link and click that. It should take you to a zip file that's like art stuff or game art stuff or something like that. Download that, extract it someplace, and then all you do to import it is you right click, import new asset, and then you find it on your desktop. In this case, it's these things for me. You just use control and you just go through and click them all, and then you click import. And what's going to do, it's going to throw all of these in here for you. Then what you can do is actually pretty simple. You just highlight all three of these things into your project like this. Change pixels per unit to 64, and then turn filter mode here from bill near to point no filter, and then turn compression to none. The reason why you want to do these last two things is because we have pixel art, and we don't want them to be blurry. We don't want them to be blurry in any way, shape, or form, because pixel art is supposed to be pristine, very sharp. Then what we want to do is right here's our jumping spaceman sprite sheet. As you can see, mine are all cut out already, but yours aren't going to be because they're probably going to be marked as sprite mode single. We don't want that. Change it to multiple. And then when you do that, just go into the sprite editor, click on the top left here where it says slice. You just click the type here and you just do grid by cell size. And then you make sure you have it at 64, and then click slice. And you will get these frames cut out like this. And you click apply. Do that for the other one as well. Do it for the running animation as well. Now, now we get to the fun stuff. We're gonna make our ground actually look like ground. That's not like some weird green blob. Thank you, Aurora, for your artwork, and we're actually gonna get that implemented right now. So what we can do is go to our tiles folder here, and I believe we can go to the grass asset. Yes, and then we just change it to this. Right there. So just go to your tiles, click the grass asset, go over here into the menu over here and change the sprite to that sprite. That should be fine. And then um let's go to our ground here and make it so it's not green anymore. We don't want it to be green. Change it to white because white just means it's opaque, or not opaque. It's a transparent then. That's what I mean. Um so yeah, now that we have this implemented, Look at how clean that looks. Oh yeah, that looks awesome. Actually, I'm gonna go ahead and make the background black. I don't really want it to be. I don't like it being blue. I'm gonna make it black like that. There we go. Cause it's kind of turning into a spacey themed game now, so it kind of makes sense for the floaty movement. Um. Anyway, now that we have that, now let's do animation. Animation is fun. I don't know if we're gonna be able to get to all the animation right away, but we can definitely try. So let's go to the graphic here. Oh boy. I believe we can actually create an animation. So what we can do is go into this window up here, go to animation, and then just open up the animation window. Then click the animation tab and or dock it someplace. And then what we do is we just click on the graphic and we click create. And then when it opens up this window, go ahead and just create another folder someplace in your project called animation. Double click that folder, and then in here we're gonna do the do running first. Or should we do walking first? Let's do running first. We'll do running. Running anim. Running animation. Okay. Um. Or well, I. eh. Okay. You know what? We'll do. Yeah. Running animation will be fine. That'll be fine. Okay. So what we're gonna do is not in the jumping animation. Once you have your animation created, just go back to your project folder, highlight these 2 frames for your running animation, drag them into the animator if you can get them in there. If you can't, like I can't, just go ahead and dock the animation window to a different area, then just drag them in, bam. And then it's going to create this little thing. Okay, this is where video editing experience comes in handy because there's keyframes and stuff that are involved with the animator in here. But now, if I were to redock this down here, and I play the animation, as you can see, it's really fast. Look at that. Look how fast that's going. Yeah, we don't want that. And we also notice our player is no longer the same size as he should be. And that's because we have the scale changed. And let's actually change the scale from 3 back down to 1. That way he is normally scaled. Then on his graphic, actually, we want that to be 1 as well. Um yes. Okay, that should be fine. Then we'll play the animation again. And there we go. You can see him. He's very, very small. We could honestly make him a little bit bigger, probably. But I think this is fine. Okay, but as you can see, it is kind of really, really fast. So let's change his sample rate down here on the bottom left. Click samples. We're going to change that to like 3, maybe? Nope, that's too slow. How about 10? And still a little too slow. 15 and 13. Yeah, 13 looks okay. 13 looks fine. Okay. So, with that said, now that we have the working animation, we want to make sure we change his default graphic as well, because his default graphic is currently the knob. We want to make it the jumping man, or just make it whatever the default one would be, which in this case is probably whatever one looks like he's on level footing. Um, then let's actually set this, or well, let's drag him downward a little. There you go. He's a little small. Yeah, he's a little small guy. Actually, no, let's just make him a little bit bigger. We'll make him 2 times bigger. How about that? I think that'll look fine. He's 2 times bigger, but whatever. Or, well, no. We'll keep it at 2. Yeah, I think that's fine. Then let's go to the hitbox here and just right click on his box collider. And then we should be able to reset it just like that. And then just go ahead and edit the collider so it looks like it's relatively, well, relatively accurate to his body size. Shrink it a little bit. There we go. Then we need to make sure we edit his raycasts as well. I mean, I know I just told you guys to change them, but we're going to change them again. Let's actually do it kind of like that. That look good? Yeah, I think that looks good. Let's make sure it works first. I don't know if it's going to play his running animation all the time right now. It might. All right, well, at least it's detecting we're grounded. That's good. Okay. So, with the background being black, it's actually kind of hard to see our current character, so I'm going to go ahead and change that back from black to like white maybe, or like maybe even like a little bit of a gray, something like that. Perhaps. Yeah, cuz I want to see if his running animation's playing. Hey, look at that. We have his running animation. So what we can do now is we can actually make an idle animation as well. So if you go back to your character's graphic, click this little drop down here in your running animation, do create new clip, and go into animation here, and we're gonna do a idle animation. And the idle animation is gonna be really simple. It's just gonna be one frame, and we're just gonna toss in a sprite. So actually, I'm gonna dock this up here, and we're just gonna toss in one of the jumping sprites, preferably the first frame of the jumping sprite. I think that'll be fine, because then when we play his animation down here, when I read it, as you can see, he's just standing still. That's fairly simple. Now we're going to do another one. We're going to do the jumping animation. Okay. With the jumping animation, going to be relatively simple. We're going to try to set it the same frame amount as the other animation was. And Aurora went ahead and made the whole jump animation for us, but we really only need the about first four. I'm assuming that looks about right. Okay. Oh god, good lord. Okay, hang on. You know, I'm just gonna dock my project window right here instead. Let's take our animations right there. Perfect. Hey, look at that. We have jumping. So what's gonna happen is when this plays, it's only gonna play up to here. And then when he lands on the ground, it will hopefully all line up perfectly fine. I think that'll be fine. I think it looks fine. Just boop. Okay. So now what we have to do is actually go into your animation folder, go to your jumping animation, make sure it's not looping. You don't want it to loop. And with that in mind, your idle can loop, your running shouldn't be able to loop, but we're going to leave it for now. Um, okay. Now this is where we're going to get a little bit fancy, because I want this to be kind of easier to set up. And normally people don't teach you this right away, but I think I'm going to attempt to teach you this. We're actually going to go into a new window called the Animator. So go to the window, animation, animator. Okay, it's going to open up this weird little image thing. Just go ahead and click on the player graphics, so then you get this window. Basically, what we're going to want to do is, I believe we just delete all of these. I don't actually want them. But what we do want is right click on, all you do is just right click in here and you can get a bunch of stuff here. We're going to want to create a blend tree. And this is where we're going to do all of our movement. A blend tree basically does a bunch of auto calculations for you and stuff. It's pretty fancy stuff. So all you have to do is click on the blend tree here, and you'll get a little window over here that pops up, and it says blend type. It says 1D. We don't want that. We want 2D simple directional. And then over here on the left, click parameters, and we're gonna click a. We do int. We do int. Int float. Int float. Let's do float. Let's do float, and we're just gonna do um velocity x, and then we're also gonna do another one, velocity y. You guessed it, velocity y. Okay. So then all we do is do parameters velocity x, velocity y, and then do the, like, you see this little motion field here. Click the plus, click the add motion field, and then we just basically what this is the motion is the animation field. Just go ahead and click on the little dot here. We're gonna do the idle animation right now. Then after that, we're gonna do another motion field. Actually, you know what? Let's just add in all of them, all four directions, or three. The three directions? Four directions. Let's do four directions. All four directions. We have an idle one at 0, 0, meaning we're just standing still. Then what we're gonna do is we're gonna have a jumping animation that will play every time our yes, yeah. Every time our y value is 1, at least. Okay, so I finished it. As you can see, we can run left and run right or whatever. This is left, this is right. I don't know why I said it like that. And then we got the little animation playing, and we can jump, see, and boop, and boop, boop. And yeah, we can just run around, boop, and stuff like that. So, how did I do that? Basically, well, first I'm going to go into the animator again. I went in and changed something. Instead of having freeform simple directional, or instead of having simple directional, sorry, we have freeform directional. Mostly because for some reason we're getting like some weird behavior with going right. I wasn't really sure why, so I just changed it to freeform directional, and it works fine. With that said, that's pretty much all we really changed in here. Basically, we have our idle at 0, 0, which means our velocity in x and y direction is 0, and means we're idle. Then if our velocity is 0 in the X, then well, okay. This is where freeform directional is very nice because our X value doesn't actually have to be 0 to get him to do the jumping thing. All that matters is that we go up. If we go up, then he'll play the jumping animation. So, with that said, our running animations are going to play when he's either running right or left. It doesn't really matter which way. As long as he's running right or left, he will play the running animation. So anyway, with that said, let's actually take a look at the code. It's actually pretty simple. I went ahead and just made two references. We have a reference to the animator and we have a reference to the sprite renderer. So just go ahead and copy that. The animator is the which component? I gotta figure out. Boom, 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 boom. The animator should be on the graphic, and it's right here. This is the animator right here. So this is what you're gonna need a reference to. Click back on our player, and then you're gonna make a reference to that right there. You're also gonna need a reference to the sprite renderer. The sprite renderer is also in the graphic, and that's right here as well. Um, with that said, in the update method, I am checking every single frame to see if the rigid body or if the player's velocity is less than or greater than 0. If it's less than 0, then we're going to flip the image so that the player's facing left. If he's greater than 0, then we're going to flip it to the right. Um, and if it's stuck at 0, then he's just going to stay at whatever direction he was currently heading. That's kind of the logic behind this little if else statement here. Anyway, moving on to the fixed update area. This is where we do some of the fancy stuff. I had a little debugging message here. Ignore that. I'm going to delete that right now. Okay. So, underneath the horizontal movement, we actually do the animator stuff, which I'm actually going to be a very kind lad. What did I just do? Okay, hold up. Oh god, I did it again. Okay, hang on. All right, here we go. So right here, we're gonna do the animator movement or the animator animation area. That's what we'll call it. Animator animation area. That's a horrible name, but you know what, whatever. So right here, we're setting the float values for each of these things into the animators. So basically, our parameters that we have over here, velocity X, velocity Y, we're setting these values right here with the set float thing. I'll make sure that this string right here is the exact name of the parameter right here. We want those to be the same, the exact same. If they're not, it won't work. Might get errors, stuff like that. But the weird thing here is, if you may have noticed, I have rigid body velocity Y here, but I have movement X here. And that's mostly because I don't want, if something were to hit the player left or right, I don't necessarily want the player's image to flip when he's trying to go against the object that he's hitting. So if he's going left and something shoves him to the right, I don't want his sprite to flip to the right. Because then if he's still holding the left arrow, it's going to look really weird because it's going to look like his input's not doing anything. So you always want your player's input to kind of override what's currently going on, sort of. It depends on the situation, but in this situation, this is what we want. So movement X is going to be like the default thing. And then for the velocity Y, we're just doing the rigid body velocity Y in the Y direction, because that way, if something were to hit us up into the air, the jump animation would still play, and we do want that. That is a good thing to have. Hang on, I want to double check. Did I forget something? Hang on. Let me play the game quick. There might be something I missed here. 1 second. Okay. All right. I see. All right. I see. Okay. Um, we want the jumping. Or actually, no, we'll do that some other time. We'll do that some other time if we ever feel like touching it up. Um, basically, what I was thinking is, actually, you know what? How about this? How about this? If you guys are so inclined to go ahead and do this, you can. But basically what I'm trying to say is, if you wanted to touch up the jumping animation just a little bit, if you wanted to do that on your own, it's like a little challenge on your own. How about that? That's what we'll call it. Figure out a way to get it so his jumping animation stays there until he hits the ground. Because right now he's switching out of it, and we don't want that. That's actually not good behavior. But I'm gonna keep it that way, and at least until next episode, whenever I feel like fixing it. If I ever do fix it, who knows? But if a little extra challenge, if you want to try to figure that out, go ahead. All you have to do is just figure out how do you get the player's jumping animation to stay until he hits the ground? How do you do that? Okay, that's for your own finding out info. Anyway, we're going to look at his vertical movement right here. Inside of the vertical movement here, since this is where we're doing our jumping, I also updated the velocity Y movement in here as well. Wait, why did I put movement Y? That is not right. That is not right at all. Yeah, it's velocity dot Y. Yes. Okay, that's how it should be. Let me make sure that still works. I want to make sure I didn't get that wrong for some reason. Let's check. All right, cool. Yep, it still works. All right. I don't know why I had that in there. Anyway, yep. So we have the set flow. We're just doing the velocity y thing again, just in case this value is different than this value. We just reassign it if we have to. Anyway, I think that's all we really did to get that movement. So you should have working movement by now. If you went ahead and you want to do the challenge exercise, go right ahead. Maybe actually I'll do that right now just to kind of show you guys that you can do it. Um, yeah, yeah, how about that? One thing I really quickly went ahead and did is instead of having the else here, I made it an else if because well, it wasn't really doing what I thought it was going to do. What you want to do is just make sure that the rigid body's velocity in the x direction is greater than 0, and make sure it's also less than 0. If we just have the else, then what happens is um when you stop moving, your character is going to default to looking right, which is not what we want. We want them to currently look wherever the player is currently going. So that actually looks much nicer. But anyway, I'm going to go ahead and do the challenge thing. Let's hope if you do it right now, you pause the video, try to figure out how do you get the player to keep his jumping animation in the air. How do you do that? Just keep it in the air until he hits the ground. Good luck. Okay, if you went ahead and did the challenge, or if you're looking for answers, I have all the answers right here. So I hope you guys enjoyed that little challenge thing. Basically, all you have to do to get your character to do something kind of like this. See when I jump, see how he holds the jumping animation all the way through the jump. Okay, it's pretty, at first it seems like it's a kind of a head twist thing, but it's a little easier than you might think. All you have to do is go in your motion field and just make another motion field, and then you want to go into your project folder here and make a new animation, call it falling. Falling is just basically a single sprite. Let's see if I can get a good example of this. Falling, play it. See how it's just the one frame. I just took it out of the falling animation. Anyway, so you just go ahead and do that. So you make the falling animation right here, and then go into your animator here, go into your blend tree, make another motion field like I said, and then you put in the falling one. It doesn't really matter where it is on the tree, but you just make sure that you put the position y as -1. Because that basically means that at any point, if the player is falling, it's going to play the falling animation. Um, and that's important. So now, if we want to go to the code, just take a gander here. I did nothing new here. Oh, right here. This is the key stuff right here. So, if at any point the player is not grounded or is not on the ground, then we're gonna set the float value for the velocity y to -1. This is going to stop a simple problem you may have been running into where when you jump up in the air, when the player hits the top of or the peak of his jump, it should zero out in velocity. So his velocity would be 0 at that point. Now, at that point is when he would stop and play the run animation for a split second, and then he would fall down to the ground. And the way to counteract that is right here. If you're not on the ground at this point in time, or at any point in a time in the game, you just set the velocity y to -1. That's all you really have to do, which honestly means we could probably go ahead and just fix up a lot of this code, but we're just going to keep it like this for now. It works. It's fine. It's not really that big of a deal. But anyway, with all that done, you should be able to get movement like this, where when you jump, he holds the animation all the way through the jump. We can just hop around. He's a really cute little space guy. Anyway, I think I got everything in here covered. Yeah, so I hope you guys enjoyed that little challenge. If you guys want me to do more challenges like that in the future, let me know. Anyway, yeah, we got our character jumping around now. We got some art involved. We got some animations. We can see our little guy running around. Look at his little legs go. Actually, before the video ends, let's actually make the camera follow him really quick. All you have to do that is just go to your CMV cam up here. If you made the Cinemachine camera, see where it says follow right here and it wants to transform. Just feed it in the player. That's all you have to do. And as you see, the camera kind of snapped. Now, if we were to run around, the camera follows us. Look at that. Really simple camera movement. That is super, super helpful. Thank you, Cinemachine. Thank you, Unity guys, for making Cinemachine. It is amazing. It is one of the best things ever. Because camera movement is just so obnoxious. But we got it working, and there we go. So now the camera follows us around. And yeah, next episode, we're probably going to work on implementing some sort of coin, maybe a coin system. We might even make it so you can jump on a platform and maybe even finish a level. Something along those lines. The coins is definitely the first thing we're going to do. But anyway, I hope you guys enjoyed. Leave a like and subscribe to see more. And I will see you in the next episode of this game development tutorial thing I am doing. Bye-bye.